evening, everybody, or late afternoon. I know the after party is starting soon, so I try to be on time. So I'm even more happy that you are still all here for the last talk of the day. I hope you still have some energy for a bit more GraphQL in Federation, because I want to talk to you a little bit about Delivery Hero's journey of migrating a very distributed services landscape with a lot of microservices and REST APIs to GraphQL, also on the client side, and talk to you a little bit about our journey, which is kind of a small, humble journey still, but I think we have a couple of interesting things to share. So my name is Arne. I work for Delivery Hero. Delivery Hero is headquartered in Berlin. And Berlin, pop quiz, Berlin is the capital of? Techno, exactly. So, but Delivery Hero is actually also the biggest food delivery platform you probably have never heard of, because it's actually one of the largest in the world. So we are active, we have 11 active brands. That's why nobody knows Delivery Hero, and it's not active in the US. But some of you might know Foodpanda in Asia, or Pedidosya in South America, or Talabat in the MENA region. So these are some of our popular brands, Yemeksepeti in Turkey. Active in 70 countries, so there's a lot of different operations and different challenges in different countries that we have to deal with. I only know like dozens of or tens of teams and thousands, hundreds of engineers, so it's more than 1,000 for sure across Berlin, Singapore, Barcelona, and some other locations. And we just reached a milestone of 10 million orders a day, actually, which we previously already reached during the pandemic, but that was obviously a little bit inflated when everybody was thinking that delivery is the only thing that we will do in the future. But now it's for real, and that obviously then translates to billions of API requests per day to do these 10 million completed orders. So I personally work on the Foodpanda platform, which is a market leader in Asia mostly, which is one of the biggest platforms in Delivery Hero. And yeah, we are all about cute little pandas and bright pink. As you can see, pink is not really my color, but everybody loves pandas, right? So these are some pictures from the office in Singapore. So today I want to talk to you a little bit about where we started, what was the problem, which I think a lot of us kind of share, which is why I don't want to spend too much time on it, because I think many of the challenges kind of repeat across different companies. But then what we found in GraphQL, and especially Federation, and our approach to it, because we were quite new to GraphQL. And then I want to talk to you a bit more about the technical details about our approach, like how did we, with GraphOS and the router in Rust and so on, all available from day one, how did we approach that from a technical perspective? Also, on the business process, because introducing something like GraphQL on a large scale in a big company is quite a challenge, as you might know as well. And lastly, I want to share what we learned so far, the good and the bad things, or things we're still struggling with. And that's where I hope that you can also take some value from it. So growth is amazing, right? The pandemic brought a lot of bad to the world, obviously, but for a delivery-based company, it meant a lot of growth, a lot of hiring, and then more teams, more features. Everything was kind of not chaotic, but there was maybe not always the biggest focus on clearing up tech debt and so on. And a lot was kind of building new things. So that can then cause problems at some point, right? The next is, this is literally kind of our architecture, which is kind of the worst case view, because this really shows everything. So, but this is not hiding anything. So there you can already see the kind of famous big ball of mud where everything is kind of connected together, many services talking to each other that shouldn't do, and so on. And that's kind of the problem that we have had after so many different new teams and a lot of growth and a lot of new services, because everybody had to own their own service and their own piece of the puzzle. So that's kind of where we started. And to just illustrate a common problem amongst our architecture, if you take, for example, these two screens, so the top is a listing screen of restaurants, like popular restaurants near you, and the bottom one would be a specific restaurant that you then double click on and see the details and see the products and so on. So in this case, for the listing, there's a vendor listing, BFF, that talks to another service that we call vendor gateway, which kind of provides you all kinds of list of vendors for locations and so on. That talks to a database, talks to an incentive service to get discounts and vouchers and stuff like that. And all of that is connected to some event stream, and then a worker is kind of writing the vendor updates to the database and so on. Then on the restaurant details page, you have another BFF that is kind of also talking to the incentive service, is also talking to its own database, and is also ingesting the same vendor data, the same pipeline that is kind of replicated between these two BFFs. So now you already see a very common problem. If the incentives team now would want to expose new data to both of these screens, they would need to align or coordinate with 3 different teams: the vendor gateway team, the vendor list backend for front-end owners, and also the details owners. This is quite a simplified view of it because there's many more dependencies that these services talk to, but that is kind of a very common pattern of problems that we had. So in short, the problems that we saw after this big growth and this expansion phase, this is stuff that you probably are very familiar with. Architecture grew more and more complex. That then resulted in performance issues, degrading developer experience because all of these alignments, and it's hard to find who owns what data, where do I find the right API, where do I find the right documentation. Documentation might not be up to date and so on. And just an increased time to market overall. Like, this is really the biggest problem that we saw, because for some features that span across multiple screens, there were so many tens of RFCs being written and so much alignment between teams necessary that it just took forever to do really big features at some point. So that's where we approached or looked into federated GraphQL. And this was actually brought to us by the client engineers. It was kind of, because my background is backend, and I was always like, I haven't looked into GraphQL for a couple of years before that. And I was like, yeah, okay, it's a nice thing to use for clients, but I wasn't aware of federation at all. And I had also my doubts around caching and the 200 status code everywhere and so on. And then I looked more into federation and all the concepts. And nowadays I'm an absolute evangelist for GraphQL and federation in the company, and spent a year to kind of get a mandate from the leadership that we can actually do this on a big scale. But yeah, we really came into the game quite when Federation V2 was already available, the Rust router was already available, GraphOS had proposals, and it's kind of all this toolset was there. We never had a monograph. We never needed to do schema stitching. We had small teams doing GraphQL in an isolated way here and there, but there was no concentrated effort. So this is why we kind of designed it from the ground up to kind of solve some of the problems that we were seeing. So what we saw in federated GraphQL, kind of the big things are then really the composability. So we saw that we could have reusable components across many screens of our application, where before we would need to implement that in different backends for front ends and all of this, which is a very common problem, I guess many of you are facing as well, or was a reason to then adopt GraphQL. We wanted to shift also the whole developer experience to the client, so that they really have one place where they go, which is the schema, find everything up to date, see everything that is available on the APIs, and just can start using all of that with a mature spec and mature libraries on the client side, and just have a much better developer experience overall. On the backend side, we saw that we could really decouple a lot of the services that right now were talking to each other, and like some nested calls where one service was calling another service and so on. And we saw that with federation, we could really pull that apart and kind of solve some of these performance issues, but also kind of domain ownership of data issues and stuff like that. And then lastly, giving teams more autonomy about their data, and really the domains being, or the teams being really owners of their data, being able to control it themselves, expose new data to the graph, not having to align with anyone, and then being really independent in how they can extend their feature set and the data that they expose. So our approach in a little bit of more detail. So on a high level, if you look at the web, the Android and the iOS applications, they do a request to the router and get a response, right? That's for the clients, that's all that matters, that's all they really need to care about. In this example, we have a vendor is a restaurant. So the input is, I hope you can see that, the input is a latitude and longitude, which would be the customer location. So I want to get all the restaurants available to this customer in this location. And I want the name, the address, the distance, the discounts, and so on. So on the backend side, how we try to split this up is having this use case layer and the data layer where our subgraphs are situated. And the use case layer is what we think about. This is actually something that Dan Berner from Apollo told me last year about. Think about the schema as the vocabulary of your platform. And that's really what the use case layer is for us. That are the components that the product team talks about with the client engineers, where the client engineers really know this is a campaign carousel in the app. This is a swim lane of recommended products and stuff like that. So these are really the components that map to concrete use cases in our application. And then the data layer is more like the raw data providers for this restaurant data, the incentive subgraph that provides discounts and vouchers and can just resolve them by ID. So in this example, then the query goes to the vendor discovery use case subgraph, and that then could fetch available vendors from another service, do some pagination, maybe does some machine learning inference to personalize the result set, and then just return the vendor codes back to the router. And since we are also requesting the name, the address, the distance, and the discounts, the router would then in parallel fetch that from the data layer based on the vendor codes. And now everybody is just responsible for the data that they actually own, and there's no duplication in terms of data ingestion pipelines and no overfetching of this data between services and all of that was before. And then obviously you have the whole flow of the data layer defining the entities, and the use case layer defines the queries, and then that goes into the schema registry, goes in, the router picks it up, and then the clients integrate with that via the CI. So that is a high-level architecture. Then another thing that we thought is really important to have a successful migration is slicing things in small deployable units, because big migrations are bound to fail, right? Or at least there's a high risk of big migrations failing, that where you work half a year on a big project and then have a big bang release that usually goes wrong. So we were really kind of keen to have really small deployable units where all of the components can be brought to production step by step, and we can, as soon as possible, learn from having that in production, get some data, having the router running in production with observability and learning from all of these things, and not do all of that at the end in a super big release. So going back to the architecture that I talked about in the last slide, here we would have the use case layer and the data layer again. So in the top you see campaign carousels, and there's a cuisine swim lane in the middle, and on the bottom there is a list of popular restaurants near you. So we would start on the screen, enable the screen to integrate with GraphQL. So you could start migrating only the first component over to GraphQL, put that behind a feature flag, implement only what's necessary on the data layer. And here we would even go as far as implementing completely mock data in the first step. So maybe the resolver just returns some fake data just so that the client engineers can start as soon as possible. And then that is not enabled for any customers, maybe just internally to check this component, and then do the same for the next component until we have the whole page migrated, so to say. And you can even make use of batching so that in the end, as a client, you make only one request to the backend, get all the necessary data for the whole screen, so you don't have a performance impact from that perspective. So this is kind of coming from story slicing in the end, if you will, or yeah, and we think it's really important to have these small deployable units as soon as possible to learn in production early. Yeah, then we wanted to get schema governance really right from the beginning. And for us, everything starts with a proposal. And proposals is something that is pretty new in GraphOS, but is something that we really thought we would embrace from day one, because it kind of makes a lot of sense for us. And with every proposal, there's always a pull request where we can then see the pull request can only be merged when the proposal is accepted. And we would only accept the proposal if the pull request has also mock resolvers that return fake data implemented, so that there's already something in the earliest step where client engineers can then start working with something. So as soon as that gets approved, there's an automation going on that creates a release candidate, which publishes to our staging variant and deploys to the staging environment. Then the router picks it up, and client engineers can kind of start validating that. And we really want to embrace having only, for now at least, having only one schema. So we really want to have small changes in the schema and push them to production as soon as possible, even though they might not be used yet. But as soon as it's kind of validated that it's not breaking anything or creating any major problems, there's a manual trigger to create a release from set release candidate. And then that again publishes to production, to the production variant, deploys to the environment, and the router picks it up, and then it's in production. And again, with this very small sliced approach. Everything is also based on tooling for us, because we found that it's really important to build a foundation first in terms of good tooling, especially for onboarding engineers and kind of giving them the tools to build everything in GraphQL. Because in a big company where priorities change and you have big migration projects like this, you never know, do you have the dedicated GraphQL team still in the next quarter, or will it be deprioritized, whatever? And then if that happens, do our engineers still have all the tools to build based on GraphQL, or would it just fizzle out and everybody would just fall back to rest and then that's it? Or you have some two half-finished things there and just a failed effort. So we really wanted to invest in the tooling as early as possible. So what we did there is we have a proof of concept playground, which is basically a small supergraph repository that everybody can just check out from Git, do a make all locally, and run kind of a supergraph with different subgraphs, where it's then easy to experiment with different directives and so on, because we also found that even the most senior backend engineers were kind of struggling to just from reading the documentation, grasping all the concepts and so on. But we really saw that once they started using or playing around with these things and the directives and how that works, how it then really clicked, and how they even became evangelists of Federation as well, because they got so excited about what it kind of would enable. So now we extended that even so that it can, this playground environment can kind of replicate from your staging variant. So it's auto-generating resolvers and subgraphs based on what's in the staging variant. So you can just have a playground locally that resembles staging, which is also obviously super useful. You could even then point single subgraphs to your local development branch, but just have the rest is kind of this mocked staging environment, which makes development locally much easier. And you don't have to deal with the real staging and connecting things in difficult ways and having inconsistencies and so on. So we're mostly Golang based, by the way, on the backend. So we have a subgraph framework that makes it really easy to create a new subgraph. Essentially, we had this already for REST APIs, and we basically extended it to also support GraphQL. So that has all the observability built in, the testing, boilerplate, all of that stuff, connecting different libraries, connecting to feature flags and so on. Everything you need, golden signals are automatically set up. Everything you need to kind of bring a subgraph online. It's not as sophisticated as was indeed presented today. That is kind of the next step, but it's kind of going in this direction. And my kind of secret plan is to just remove the REST support from that framework so that nobody has a choice but to use GraphQL in the future. Then on the client side, we integrated the Apollo SDKs, and we made sure that on every screen, the whole infrastructure for GraphQL is already there. So if you want to start migrating a screen to GraphQL, you don't have to kind of wait for someone or build all the infrastructure to really use GraphQL, but you can just start using it for your new component. It's already there. So that it's kind of a no-brainer to just do it in GraphQL when you create a new component, but also that it's easier to migrate existing components. And lastly, what is also super important for us is, for all of us, I think stability and scalability. Obviously, we have a very peak time sensitive business because people tend to want to eat at the same time during the day. So if you are down in that time frame, you lose a lot of money in a short time frame. So and we have these big weekly operations meetings where all the incidents get reviewed, and you don't want to sit there with 200 engineering managers and getting questions like, why is this shiny new GraphQL thing failing when the glorious REST API is still working fine? So we really wanted to make sure that we have everything in place on the router from the get-go. And then lastly, all of that also obviously has to be based on good documentation and run books and guides and so on, which we're still working on. Not all of this is perfect yet, but we found that these are kind of the building blocks that we need to have a successful migration on a larger scale. So in terms of the router safety and general, protecting us against incidents and so on, what we mainly do there is, first, as I already mentioned, only schema changes only with an accepted proposal, right? That's the first thing, so that nobody can just publish whatever they want in the schema and do. We want a healthy evolution of the schema in the end. We use persisted queries as a safe list for production so that engineers can do whatever on staging, test things around, experiment, but when it comes to moving that to production, there's always this validation step that we can make sure, okay, this is actually load tested properly, it's actually performing in a sensible way, it's not doing crazy things in the background that are super unoptimized. So at that point, we can kind of still find problems, which is obviously still quite a manual process and might not scale well once we have dozens of subgraphs. For now, this works well, and we probably would need to find a way to automate that a bit more. And then lastly, we have a lot of isolated environments for the biggest markets that each have their own router and subgraphs deployment to really reduce the blast radius of incidents so that it's at least kind of contained to one market if we have a problem. Because the single point of failure of the router was actually something we got a lot of pushback on internally. Like, people were really uncomfortable with the idea that now every request goes through the router, and if that's down, then everything is gone. So we try to reduce that risk as much as possible. So yeah, what we learned, a couple of things, the good and the bad. Embracing the schema, I think this is something that we already see today is quite amazing because it really facilitates this discussion early and often, and a lot of problems in how teams think about their scope and the data that they expose and how it's used by other teams. A lot of problems around that now surface much, much earlier than before, where it was in many cases already too late to fix them, and then you had to do some weird workarounds to still make things work. So this is obviously also time intensive because there's a lot of discussion going on how to name types, how to relate them, what should be an entity, what shouldn't be, and so on. But it really, in the end, I think is a net benefit because it also brings a lot of understanding to teams on how their data is used and how clients expect it to be used and so on. So the schema is really serving as a vocabulary of our platform. And in the end, also for the clients, it's awesome to not have to find a dozen different backend API owners and documentation endpoints and so on, but always have the schema to go to. We had some challenges with nullability. So when you start with a single subgraph, these things are pretty clear, but once you go to the federated world, it becomes a little bit more challenging. So one example would be you have this vendor lists of vendors, and then each vendor has a code. The is favorite, like that did the customer favorite this vendor, name and rating. And then, for example, for is favorite, this is non-nullable, right? Why would this not be true or false? It's either yes or no. But now if we would want to move is favorite to its own subgraph, because maybe there's a team owning this whole piece of data, then if it was a non-nullable field and that subgraph was down, we would have a null for is favorite, which is not possible. So the null is bubbling up to the vendor. And then the list is also non-nullable. So you're basically nuking the whole vendor list just because this uncritical field essentially is unavailable, or that subgraph is unavailable. So we would want to make that nullable in the new subgraph. But obviously that doesn't work because it's a backwards compatibility breaking change. So this is something where we then had the problem on how to kind of handle that. And in the end, we had to settle for still making it non-nullable. And then there's always this trade-off of convenience for the clients versus safety on the back end, or comprehensiveness versus simplicity, if you will. And this is kind of something where we are a bit unclear on also, because it feels like the meaning of null gets lost a little bit because it's not clear if it's like subgraph failure or actually an intended value that has a proper meaning. But there's also a lot of, regarding that, there's a lot of discussion going on in the community around client-side nullability and so on. So we're really quite excited for that. Other challenges we had were around field migration. So Federation allows field migrations without the clients really knowing or caring, unless you need to correct past mistakes. Like the is favorite field, if you then want to make it nullable, you need to rename it. But how do you name it? Is it then is favorite v2 new or nullable? So that was always kind of, we didn't really find a good practice there, because we can deprecate fields and introduce new fields, but there might always be app versions of customers that haven't been updated for 2 years, and then it's kind of a painful process to migrate that. Schema evolution is encouraged, but naming fields is hard. Then the override directive in the enterprise license enables you to put these traffic weights, this label, to kind of move traffic percentage-wise from one subgraph to the other. But that makes rollbacks a bit challenging because it's defined in the schema. And since we have this process of having a proposal and mandatory, now if you figure out that your new subgraph is not working and you want to revert that traffic override, you need to create another proposal to set it to 0 again, create a new release and all of this. I also saw in the talk in the morning from Coinbase that they solved this with coprocessors, which was quite interesting. So this could solve that challenge. And in general, we found that for our engineering team, like understanding all the intricacies about override, shareable, provides, and how all that works in tandem or not, can be a bit challenging. And we really needed to make step-by-step guides on how to set up a field migration, for example. What's next for us? Yeah, just in the interest of time, I will just quickly go over this. So these are just a couple of things we want to do in the future that we're doing right now, experimenting with coprocessors and connectors and so on. And we want to contribute back to the Go community, write a little bit about our learnings as well. And lastly, as kind of the main takeaways, I mean, a lot of this is kind of common sense, but some things are really good to always highlight. Like we believe a strong schema governance process is really key from the beginning to have a healthy schema evolution, and having that as kind of top of mind of all the engineers, that there's a proposal and starting the discussion as early as possible, not doing these last minute changes, has really helped us. Establishing best practices in terms of tooling around testing, observability, router safety as well, is really important. Then incremental delivery, delivering these small slices of your application that are migrated to GraphQL. Learn early, expose it to a limited amount of users, but at least get some data on how it works, how you handle incidents. and how you can kind of recover if things go wrong. And also, lastly, bring the product team on board. They shouldn't think about, oh, this GraphQL thing is just to fix a lot of tech debt. They should really think about this as the new way of the engineering team building things, and kind of, because they also benefit from looking at the schema and having everything represented there. And this really helped us also to get the buy-in and then the time that we need to really focus on the things. And so it's not just seen as an engineering investment that nobody else cares about. So yeah, these are the main takeaways. I'm out of time, but thanks a lot. If you have any questions, I'm also at the party afterwards, so would love to have a beer. Otherwise, thanks a lot.